Comparison between SN1 and SN2 reactions.
Here is the comparison between SN2 and SN1 reaction. SN2 reaction is going to involve only one step, and that one step is the rate determining step. Whereas in SN1, there are two steps involved in it, and the first step is the formation of carbocation. In the case of SN2 reaction, it is a bimolecular rate determining step, which means there are two species which are involved in the rate determining step, which is basically our alkyl halide and the nucleophile. But in the case of SN1, it is a unimolecular rate determining step, which means it is only the alkyl halide that's going to take part in the rate determining step. So the rate is only decided by the nature of the alkyl halide. And the third one is that the rate is controlled by steric hindrance. Remember, in an SN2 reaction, the primary alkyl halides are more reactive, or even the methyl halides are more reactive, right? And then your primary alkyl halide, and then comes secondary. And the tertiary alkyl halides are almost unreactive in an SN2 reaction. And that's because of steric hindrance. Whereas in the case of SN1 reaction, the rate is controlled by the stability of the carbocation. It's going to follow exactly opposite because the tertiary alkyl halides are able to form the carbocations very easily, or it's going to form the stable carbocations, and therefore the rate is going to follow this order. And in the case of SN2 reaction, when the carbon where the halogen is attached is the chiral center, it's going to lead to the formation of inverted product. Okay. Whereas in the case of SN1, it's going to lead to both retained and as well as inverted configuration, with sometimes more of the inverted configuration, with slightly more of the inverted configuration form. And the nature of the leaving group is going to follow exactly the same order in both SN1 and as well as SN2 reactions, where you can see that the I- is still be the best leaving group because it's the weakest base. In the SN2 reaction, you want the nucleophile to be a stronger nucleophile, only then the reaction is going to be faster. Whereas in the case of SN1 reaction, the nucleophile doesn't play any role in the rate determining step, and therefore it doesn't affect the rate of the reaction because it only comes in the second step of the SN1 reaction. Here is the comparison of SN1 and SN2 reactions with respect to substrate. If it's a primary alkyl halide or methyl alkyl halide, it can only undergo SN2 reactions. But secondary alkyl halide, most prominently, it's going to undergo SN2 reaction, but it can also undergo SN1 reaction, depending upon the conditions. If it's a tertiary alkyl, allyl, or benzylic halide, then it's going to be going through only SN1 mechanism. And if it's a primary and secondary allylic benzylic halides, then it can undergo both SN1 and as well as SN2. But when it comes to vinylic and arylylic halides, they do not undergo SN1 or SN2 because under SN1 they do not form a stable carbocation, and under SN2 the nucleophile is repelled by the pi electron cloud. So because of which they cannot undergo SN2 reaction.